Hi guys, welcome to my channel. All right, now in this particular exercise, I'm going to walk you through schematic diagram and ladder logic. I'm going to tell you the difference between these two logic. Okay, this one is schematic, this one is ladder logic. All right, we use this particular control circuit to illustrate the sequence operation of a particular process. And this one, we use symbol of a component to represent the sequential manner in which a particular process is being controlled. This particular logic now is our ladder diagram. This is the particular diagram we use to write a program and download into a PLC. Okay, all right, those of you aspiring to come into automation space, you are going to meet this logic. Okay, it's a very popular logic we use to write a code. All right, now I'm going to walk you through difference between the two symbols. This one, they are all ladder symbols and ladder logic symbol. Then this one is a schematic symbol. Okay, all right, both of them does the same thing in terms of input output. All right, the same control. So let's work according to the symbol and according to the instruction. Now this particular supply is my positive supply. We call this one run. Okay, this is my supply here, negative, here, positive. Then this particular horizontal network here, this logic here is what we call network. I have two network now, network 1, network 2. Okay, then these symbols, we call them bit. We call them input bit. Okay, and it's also our start push button and our stop push button. They are all input bit. In automation language, we call it input bit. These ones, the whole of this, they are all input bit. So the bit now is going to be regulating the output behavior. All right, the instruction of the input is not going to be arranged such that the output will understand the logical representation before we have a response from the output. So this particular one is my output bit here. This is the symbol for my output bit. This one is also my output bit. So I have only two output here. The rest here are input bits. Okay, they are all input instructions. Now here, this particular network is going to represent the whole of this logic. The whole of this logic that I have here is what I represent with this network. Okay, this is my overload. All right, and this is my normally closed bit. This is also my normally closed bit. This one open here is normally open bit. Okay, so this is how you recognize normally open and normally close. Okay, we also have normally open and normally close here. 1, 2 here, they are normally open. Here is normally open. This one is normally open. This one is normally close. NC, normally open. NO. All right, the same language. Both of them use this common name, NCNO. All right. Okay, now let me walk you through the operation sequence of this. But first of all, let us recognize the symbol and reconcile them with this. This is my fuse. I don't need fuse here because PLC is an intelligent device. It's well protected, it's well articulated, the function of it is well designed. A lot of safeties are there put in place. Okay, so I don't need fuse here in my logic. This overload, I have overload here. This is my overload. This is my stop push button. Okay, both of them are the same thing. It's just the name is what is going to be changed. Okay, let me see if I can put the name. Overload here. Sorry. Or I can also complete it. So let me put it here. Oh, it's very big. Let's drop the size. Okay, this is my overload. I can put it above. So this is my overload. Then this is my stop button. So I put stop button. Let me just put stop. Okay, put it there just for space factor. This is stop button. This is overload. Then this is start button. So I'm going to put FW. I'm going to abbreviate that LWD for forward start. It's going to be FWD. That is for forward operation. So that is this one. This is my forward operation button. Okay. Then this one is going to be backward. My reverse button. Reverse operation button. Yeah, like this one. Okay. All right. Then this one is my K1. Let me say K1 contactor 1. Sorry. And this is going to be K2 contactor 2. Okay, that is K2 contactor 1, contactor 2. All right. Then this one is start button for backward counterclock operation. This one is start button for clockwise operation. This one is stop button. Whichever one that is being activated will be shut down through this stop button. Then this is overload, protecting the entire system from mechanical friction and resistance. All right. So let's relate them here now. Like I told you, this is my output. What I have here is input 1, input 2, input 3, input 4. Only 4 input is what I have in my logic. Then I have 2 output only. Okay. So the connection required here to PLC is 1, 2, 3, 4, 5, 6 only. That is only 6 physical bit connection that I have to do to my PLC. Okay. Then when you come to my schematic, I have, like I said, we don't need fuse here, so omit this. We don't also need phase failure. This symbol is for my phase failure, and this is the component of the phase failure, and this is the um, contact here. So we don't also need phase failure here. PLC is an intelligent device. It can handle all that. Okay. Now, this is my thermal overload, and this is my thermal overload. This is symbol. Then this is phase failure. I don't need it. This is stop button, and this is my stop button. Now this is forward operation start button, which is this. Now this is my electrical interlock, and here is electrical interlock. That is K1. Okay, this is K1. Okay, we can as well add K1 there. It's going to be K2. Sorry for interlock. This is K2. Then this is going to be K1. This is going to be K1 to interlock the two, not to close simultaneously. All right. Okay. Now this is my stop button, and this stop button, start button, start button. Then once this one is activated, here get energized, here will latch this. The same way, once this one is activated by pressing here, here will latch. Look at it, K0, K0, sorry, Q0.0 and Q0.0. So let me K1. This one is also K1. Okay, this coil is one of my contactor for forward operation. So this is going to latch this. The auxiliary contact of this is what I have here. All right. The same way, I have this as my K2. This is my K2. This auxiliary contact of this belonging this. Once this one close, the auxiliary will latch this. Okay, so this one is lashing function. This one is doing the lashing function. All right. So now come here. I have this lash here. These two, K1, KM1, KM2. All right, KM1, KM2. So the auxiliary contact of this is this one, the same way. So this logic is what I have here. So this is the ladder logic, and this is the schematic. Okay, this one is a schematic control circuit. Then this one is a ladder logic program program logic for PLC. Now let us simulate now. I want to put on this K1. I press this button. This one come up. Look at the indicator. I want to shut it down. I shut down from here. I want to start the K2. I put it on from here. Look at the indicator lamp as well. All right. So I want to shut down. I shut down from here again. I have this logic more than 3 in my page. Okay. All right. Now I want to simulate the ladder logic. Look at it. This is my start button. Pay attention to this contactor, both of them, so that you know when they close. Don't be deceived about this. By the time you register for the course, you will understand this bit and their behavior. But use this blue dot line to understand the flow of current. Okay. All right. This one will turn to this blue when the current is flowing. So let's do that. I put on this. This one is on. This one is activated. This logic forward operation is activated now. If I want to shut down, I shut down from here. If I want to activate this one, I put on this. If I want to shut down, I shut down from here. Okay. Now there's one other thing. The lamp here. Let's illuminate whenever both of them is active. Let's do that. We can use this. We can use this. But this is the bit here. Just hold on. I want to do that. This is what I will do. Okay. I'll now put this one to be K1 running, or I can now say Q 0.32. I have 2 already. Q 0.2. Then this one is going to be Q 0.3. So I have how many output now? I have 4 output. 1, 2, 3, 4. The same way this one 1, 2, 3, 4, 5. Okay, because I have overload here. All right. So this one will illuminate when forward operation is being energized. The same way this one will illuminate for backward operation. Then I feed them. Sorry. So we are going to introduce the bit auxiliary. Put them here. Put the bit auxiliary here. And put this one here. So this one now is going to be my Q 0.0. Once this one closes, the auxiliary bit here will close to give me this indicator. The same way here, I'm going to have Q 0.2. All right. Then I feed them to the lamp to illuminate whenever any of the operation is on. Okay. This one should project more. Let's see if we can. All right, let's see. This one is for forward operation. This one is for backward operation to illuminate and alert us when the operation is on. But backward, I can change. Okay, let's simulate and find out. Okay, I put on this. There is error. We are having error. Q0.2. Oh, sorry. This one is going to be Q0.1, not 2. Then this one is Q0. Sorry, Q0. Yes, I have 0, I have 1, I have 2, output 2. Yes, supposed to be output 2. Then output 3. So why am I having 0 for this one to close? Then this one should be 1, sorry. This one should be Q0.1. All right, let's test again. I put on this first one. Yeah, this one should come alone. This one has closed. The auxiliary here is closed. Give me this one. I shut down here. Then I want to activate this. I put on this. Okay. All right. Now watch. When this one is running and I try to activate the second operation, look at it. It cannot go because the auxiliary here is open. This auxiliary interlock here, electrical interlock here is open. So it cannot go until you deactivate the first operation before this one can go. And once this one is running, this one cannot go as well because the interlock is there until you deactivate the first operation. Similarly, the same way, if I want to simulate this, if I put on this, if you try clicking this one cannot get energized because it's open. Until you de-energize this, that is when this one can come in. And once this one is working, this one cannot come in. So that is the essence of electrical interlock. Okay, then for more clarity, we can take away this. Then I will put normal pilot lamp to illuminate for you to see. Let's change it with this type of lamp. Okay. All right, let's do that and see the results. So I want to feed this. I want to also turn this and use this so that I can visually see the illumination. All right, so let's see if we can simulate this. All right, now I put on this operation. Yeah, this one is on. I shut down from here. I put on the second one. This one is on. All right, then let me create another button for overload. Let me put another button here for overload. So in that case, I'm going to have 0.1. I don't have I 0.1. I should have overload block before this can respond. I'm supposed to have a power circuit, but no, I have a very tight space factor here. I would have created power circuit before this control circuit. So with that power circuit, we should have something of this. We should have the overload block. Let me show you the overload block. This is the overload block. So we're going to have something like this. This overload block is one having this auxiliary contact. So until this one is getting energized, let me see if we can simulate it now. All right, when this one is activated, that is when this one will get de-energized and this one too will get de-energized. Okay, but I don't have power circuit now. All right, Okay, it's even working now. Look at it, it's working. It's now deactivating here and yet coming out this one. So what I would do now is to have it and change the name to let me create two. Let me make it two here. This one is going to be for this other logic. Oh, then this second one is going to be I 0.1. Okay, this overload is going to take care of this logic. Then this one take care of this logic. All right, is the overload block that comes after contactor. Okay, so let's simulate. I put on this. This one is working. Let me create a fault by activating here. It's not responding. This one is not responding. Okay, just hold on. Let's try once more. I want to find out something. I put on this logic. It's running. Oh, yeah, it's working. I'll create the fault from here. All right, so it's better. Okay, now when this logic is on, when the forward operation is working, and I have a fault tripping from here, so let me activate this. So the system shut down. So in that case, I don't need this block. I don't need that block. So put on the system. I can create the fault from here. Once I create here, then this one will shut down. But that fault is actually coming from overload block. All right. Okay. So that is how this logic functions. This one is for overload to cut off during a friction or a resistance from a mechanical mechanism. Okay. Then for this area, let's simulate once more. I put on this. This one is running, and peradventure there is a fault. This one will get activated, and here will open, and this one will close. This bit, this particular auxiliary, and this one, they are the same integral part to this. This one is NC, this one is NO. Once this one open, this one will close. Both of them change state, and this alarm will come up. Okay, until you reset the system before the alarm will, you are able to start again. If you don't reset the system, if you try starting again, you cannot start. None of them will operate until you reset the alarm. All right, thank you. This is how you will learn difference between schematic and the ladder diagram. All right, share and comment and like. Okay, then you can now as well forward to your loved ones, forward to students who are also aspiring to be into automation space. All right, thank you.